current and circuit. We are familiar with air current and water current. We know that flowing water constitutes water current in reverse. Similarly, if the electric charge flows through a conductor, for example through a wire, we say that there is an electric current in the conductor, that is a wire. In a torch, we know that the cells or a battery, when placed in proper order, provide flow of charges or an electric current through the torch bulb to glow. We have seen also that the torch gives light only when its switch is on. What does a switch do? A switch makes a conducting link between the cells and the bulb. A continuous and closed path of an electric current is called an electrical circuit. Now, if the circuit is broken anywhere or the switch of the torch is turned off, the air current stops flowing and the bulb does not glow. How do we express electric current? Electric current is expressed by the amount of charge flowing through a particular area in unit time. In other words, it is the rate of flow of electric charges. In circuits using metallic wires, the electrons constitute the flow of charges. However, electrons were not known at the time when the phenomenon of electricity was first observed. So, electric current was considered to be the flow of positive charges, and the direction of flow of positive charges was taken to be the direction of the electric current. Conventionally, in an electrical circuit, the direction of electrical current is taken as opposite to the direction of the flow of electrons, which are negative charges. So, let us now have an equation. If the net charge Q flows across any cross section of a conductor in time, then the current I through the cross section is I is equal to Q by T. The SI unit of electrical charge is Coulomb C, which is equivalent to the charge contained in nearly 10 to the power of 6 18 electrons. Now we know that an electron possesses a negative charge of 1.6 into 10 to the power of minus 19 C. The electric current is expressed by a unit called ampere, named after the French scientist Andre Marie Ampere. 1 ampere is constituted by the flow of 1 coulomb of charge per second. That is, 1A is equal to 1C divided by 1 second. Small quantities of current are expressed in milliamperes. An instrument called an ammeter measures electrical current in a circuit. It is always connected in series in a circuit through which the current is to be measured. Now this figure shows the schematic diagram of a typical electrical circuit comprising a cell, an electrical bulb, an ammeter, and a plug key. Now note that the electrical current flows in the circuit from the positive terminal of the cell to the negative terminal of the cell through the bulb and ammeter. So let us have a look at the figure, schematic diagram of an electrical current. Now this comprises of a cell, the electrical bulb, ammeter, and a plug key. So let us have an example. Suppose a current of 0.5 ampere is drawn by a filament of an electrical bulb for 10 minutes. Find the amount of electrical charge that flows through the circuit. Now what is the solution? We are given I is equal to 0.5A, that is the current I. T is 10 minutes, which is 600 seconds. And from the equation, what is the equation? 1 ampere is equal to 1C divided by time. Therefore, the equation is we have Q is equal to IT, that is I 0.5 ampere current into T, that is second, 300 C. So that is how we calculate. It's the basics of fundamentals of electricity.